I'm going to give you these answers first, so you have the choice of moving through this a little more quickly. That number 4 is 1/6. Number 5, there's two things you could have said. You could have said probability of 20 followed by 10 after 20. But you really wouldn't need to say all this. You say followed probability of 20 then 10, because it by definition it says two dependent events, so that implies the first bill is not replaced. Or probability of 10 followed by 20. Either one of those will result in a probability of 1/10. Number 6, how many pictures are in the photo album? 40. If a picture is selected at random, what is the probability that shows both Nikki and Luke? It's 15/40, which simplifies to 3/8. Now I'm going to go over these three so you can get whichever one that you might need help with. Number 4, John is stacking bricks to build a fireplace. A box contains 2 red bricks, 2 red, 3 white, and 5 gray. Find the probability of white then gray if she selects 2 bricks from the box without replacement. Probability of white, there are 3 favorable outcomes and 10 bricks in the box. And then she doesn't replace the white, so I'm just going to cross off 1 white. The probability of selecting gray after white without replacement, there are 5 gray out of now 9 bricks. The 3 and the 9 simplify to 1/3. The 5 and the 10 simplify to 1/2. And so that's how I get the 1/6 for those dependent events. A wallet contains 3 $20 bills, 1 $10 bill, 2 $1 bills. Name 2 dependent events that will result in a probability of 1/10. You have to work backwards on a problem like this. And so I think of first I think of how many possible outcomes do I have? I have 6. Interesting. It's really, look, there's a guess and check approach, and there's not too many things to guess at before you'll stumble onto the right answer. But maybe a better method would be to think of what 2 fractions would I multiply together to get 1/10. I can only get 1 if my numerators are both 1. And the only factors that will give me 10 other than 1 and 10, and I don't think it can be 10. I don't think, first of all, this can't be a 1 and this can't be a 10, because 1/1 means I have a certain probability for one of these events, which there's no dollar amount you could choose that would give you a probability that would be certain. So I feel like the denominators must be 2 and 5, the only other factors of 10, 2 and 5. But, there are more than 2 possible outcomes. There are 6. But what would the numerator be that would, if I have some number of 6 equaling a half? It must be 3, right? So in order for this to be a half, it would have to be picking a 20. There are 3 20s to choose out of 6 possible outcomes. So the probability of a 20 is 3/6. Once one of those 20s is gone, I want a probability of 1/5. Well, there are 5 possible outcomes and only 1/10. So if you multiply by the probability of 10 after the 20 is picked and not replaced, that is 1/5. And so that's a half multiplied by a 5th. This is why I said this is one of the possible answers. You also can, because of the commutative property, it could have been 10, probability of 10 followed by 20, because if I go back to the original situation, there was only 1 $10 bill out of 6 bills to choose from. But once that 10 is gone, there are 3 20s out of 5 bills. And the 3 and the 6 become a 1 and a 2, and that's another way to get 1/10. So $20 followed by a $10 or $10 followed by a $20. I don't feel like that was maybe the best explanation, but that's what the 130 zoom is for. If you want a little bit more clarification on any of these. A photo album contains, as I read this, let me just say something. There are many math problems that are worded like this. There's some of this, some of that, and some of this and that. Anytime you hear some of this, some of that, and some of this and that, you should make a Venn diagram. A photo album contains some pictures of Nikki, some pictures of Luke, and some pictures of both Nikki and Luke. Classic Venn diagram model problem. Nikki, Luke, Nikki and Luke in the intersection. Nikki is in 25 of the pictures. That doesn't help me put a number in my model at all. I just know that there should be 25 Nikki pictures. The reason I can't put a number is I don't know how many of them also include Luke. These two regions have to add up to 25. You remember when we did Venn diagrams. Luke is in 30 of them, so these two regions are going to add up to 30 for Luke. Nikki and Luke are together in 15 of the pictures. Now I can do something. I know the intersection is 15, so I know there must be 10 Nikki only pictures and 15 Luke only pictures to make the numbers work out. How many pictures are in the photo album? Now that I've got my Venn diagram, 10 plus 15 plus 15 is 40. This is how I got the 40. You could also, without a model, although I would always recommend the model, you can add those together and you got 55. You subtract 15 from 55 because you don't want to double count the pictures that they're both in. And that will also give you the 40. We've done some geometric problems or with an overlap like this. So this is a common thread or a common idea that or a recurring theme. If a picture is selected at random, what is the probability that it shows both Nikki and Luke? Well, if 15 pictures show both Nikki and Luke, and there are a total of 40 pictures, there's a 15/40th probability of the picture having Nikki and Luke. And then the common factor is 5, so this becomes a 3 and this becomes an 8. So in simplest form, it's 3/8.